Welcome to another episode of Code for Thought ByteSized RSE, sponsored by the Universe HPC program. Yes, ByteSized RSE is back with a brand new set of 6 online classes and podcast episodes covering a range of different areas for all of you busy researchers who write, update, and/or manage software. And we're going to start with a topic you might have come across before: containers. What are they, and why should I use them? And as per usual in the bite-sized episode, you'll hear from someone who uses containers a lot. And this time it's Simon Lee from the University of Dundee, and you'll be hearing from Simon a bit later. And right at the end, I put together a couple of quiz questions that you can mull over at your leisure. So I hope you stay with me until the end. But let's get started with containers. I appreciate that some of you may have never heard of containers or indeed virtual machines for computing before. But I suspect that many of you have, like for instance a tool called Docker, or perhaps even Kubernetes. In the last 10 years, containers for software have become rather widespread. What they do is to let you run an application, or indeed several applications, in sort of isolated or self-contained environments, hence the name. In the online class that Jeremy and Steve ran, you will have practiced containers with a tool called Podman. But for many years it was in fact Docker that reigned supreme. And Docker is of course still widely used. It was released in the year 2013, so at the time of recording, 11 years ago. But the concept of running software in separate and self-contained environments dates back a lot longer. It started with an operating system called Unix. And in 1979, version 7 of this operating system was released, and it contained a command line tool called change root, written CH-root all in one. Change root made it possible to change the root directory of a process and its child processes. Okay, so why does that matter? Well, with this tool, a process running in a particular directory and all child processes that are spawned from it is usually not able to access any data outside the directory tree it sits in. In other words, it was an important step to separate the running of different processes from each other, a step that led to the development later on to so-called process jails. And that happened in the year 2000, so quite a little bit later, with the release of a Unix variant called the Free Berkeley Software Distribution, or FreeBSD for short. In the words of the FreeBSD manual, FreeBSD jails were developed as a tool for system administrators to enhance the security of a FreeBSD system. And further down it says that jails were created to expand upon the change root concept, which is used to change the root directory of a set of processes. Jails create a safe environment independent from the rest of the system. Processes created in this environment cannot access files or resources outside of it. For this reason, compromising a service running in a jail will not compromise the entire system. Arguably, the most popular Unix variant is the Linux operating system. And in 2006, Linux introduced namespaces and control groups to its kernel, that is, the core of the Linux operating system. From then on, it was a short step until 2008, when Linux containers, or LXC for short, were introduced. There are a number of other tools, like for instance Warden, or Let Me Contain This For You, LMCTFY for short, because we do love acronyms. But putting together a container was still a bit of a kerfuffle. Well, right until the year 2013, that is, when Docker came along and presented a solution that made the whole thing a lot easier. And because of that, Docker quickly gained a lot of traction and since then has been widely used by software engineers the world over. Kubernetes, another tool I mentioned earlier, followed suit in 2014. On high-performance computers, a tool called Singularity was introduced in 2015, which is now actually being called Aptainer. Which brings us forward in the time to 2019, when one of the major Linux distributors, Red Hat, released version 1 of yet another container tool called Podman. And if you took part in the class with Jeremy and Steve, Podman is the tool you used. Okay, enough of the history now. Let's talk a bit more about what makes a container and how they're run. Self-contained environments and processes. What does all of that actually mean? Let's start with process. A process is, in a way, an instance of a computer program executed on your computer. In doing so, it has to access various components and hardware, for instance, access to write and read from memory for getting and storing data, the use of the graphics card, for instance, or, of course, the central processing unit, the CPU. It's your operating system that usually is managing all of that, and the operating system itself is consisting of a number of programs. Okay, I'm probably preaching to the choir here, and you might know all of that already. And you may also be aware that accessing system services, such as hardware drivers, is a dangerous thing. Because if you make an error, you can damage the system and may not be able to run it anymore. And so operating systems usually define process boundaries, for instance, between what the system operations can do and what user applications can do and access. Just like privileges for system administrators, which are different from the ones that standard users of a system get. Containers are an extension of that concept, in that they define a boundary in which applications can run. They create a virtual environment which contains everything that's needed by your app. But since it is rare that applications use every single resource and component of a computer, what a container needs is usually considerably less than a full system. And this makes containers rather lightweight and also very efficient to run. The things that are being loaded into the container, and by that I mean the executable instructions, like an application, are called images. For instance, if you want to run a database like MySQL in a container, and there are good reasons for doing that, by the way, you can download a MySQL image from an official hub like Docker to load it and make it available in your container. Which is yet another advantage of using containers. You actually have a large number of available images you can run out of the box. Container managing tools like Docker, Podman and others also allow you to do much more, like loading data into it as well and install components, etc. Container technologies are really tied to the Linux operating system, as I mentioned before. In short, when we talk about containers, we really talk about Linux. Linux is, of course, very popular and on high-performance computers, the de facto standard. Alas, as popular as Linux distributions are, there's still a very large group of users and developers out there who run different operating systems, like Windows, for instance, or Mac OS X. So how would you run these Linux container solutions, like Podman or Docker, on Windows or Mac OS machines then? Can you even do that? The short answer is, yes, you can. Because both Docker and Podman use a so-called virtual machine with a basic and lightweight Linux kernel that allows them to run the container solutions on your machine, even if it's running Mac OS X or Windows. Virtualization and virtual machines are a very interesting and exciting subject to talk about, but unfortunately they're way beyond the scope of this episode. And luckily, both Docker and Podman, and other solutions as well, of course, hide most of the complexity from you anyway. Okay, so now we know that with containers you load images of applications and data and run them in their own environments, that container solutions are based on the Linux operating system, and that you can run tools like Docker or Podman on Windows machines or Macs. Which of course is all very well, but why on earth would you actually bother? If it were only down to sharing an application with others, say your team members for instance, why not just share and use the same binary, that is, the machine-readable format of your application? And of course, this would work just fine, and in fact is how in many cases applications are being distributed. And it works if you run the same operating system that can run the binary version of your app, if you have everything the app needs installed on your system, and if the installed software and operating system versions are compatible with what the app depends on. Well, that's a lot of ifs, isn't it? For one, you can't take for granted that everybody is running the same operating system on their machines as you do, or indeed have the same software installed, not to mention the right versions of the software that are compatible with your app. Say your tool relies on a Python version of 3.7 or higher, but others are still using older versions of Python. Your app may crash. Or say you would like to use a database like MySQL or Postgres. They're both open source and you can download a version and install it, of course, but there are quite a few setup instructions to follow, and it may take some time to get your hand around them and how to configure it all. So wouldn't it be nice to get a production-ready system that it can run out of the box more or less, without worrying too much about what version it's in, or having to do long and tedious setups and configurations? Which is, of course, where containers come in. You want to run a web server? Well, get a container to do so. In one of my previous roles, we built a system that consisted of several containers. One to read images from a medical imaging tool, which passed the data onto a container with a database, and a separate data processing container, which made it available to a website run yet in another container. Running and orchestrating multiple containers is a subject in its own right, and I'm not going to get into that. But the relative ease in which you can run, create, share, and deploy containers and the images that run inside them explains why they've become so popular. And for researchers, and this is something we haven't mentioned yet, there is yet another very important reason for using containers. And that is that it helps to make your research software both more reusable and more reproducible. Which brings me to my interview, finally, with Simon Lee. Simon works with containers a lot, as he explains in the following conversation.
I'm Simon Lee. I'm a Senior Research Infrastructure Engineer at the Health Informatics Centre at the University of Dundee.
The subject for today is containers, and what I would like to know from you is, what role do they play in your work?
In the past, I've used Jupyter quite a lot, and I'm involved in the Zero to Jupyter project, which is basically a way of making Jupyter available on Kubernetes. So for anyone who doesn't know, Kubernetes is a way of orchestrating containers. It was originally created by Google like several years ago. It's now really popular, and it's a really easy, nice way to basically run containers across multiple nodes. And nowadays, I'm more working with AWS at the moment. So I use AWS's container service, the Elastic Container Service, and that's a convenient way for, say, running, say, services like Keycloak or, say, on the web proxies or whatever.
That brings me right to the question that I had anyway. So you answered part of it. So Kubernetes is the technology that you use, which is to orchestrate containers. But as a container technology directly, what do you use there?
So one thing about Kubernetes, it kind of abstracts away some of that underlying stuff. But generally at the moment, I think it's Containerd. In the past, something called Docker.
Stepping away a little bit from the technologies and specific technologies and specific container solutions, in general terms, what do you think the benefits of using containers are?
I think the main benefit is just sort of reproducibility of deployments. So the thing with the container is you can basically build a container, you package up all the software, and more importantly, all the dependencies, which can be like complicated, put up on a container registry, and then anyone else can pull it down. So that's really good for reproducibility. And even if you're just using it privately, I think it's really good. But if you're doing sort of complicated infrastructure, typically it's like storing databases somewhere, then you've got to install a web app with loads of dependencies, and doing that manually is just going to be a massive pain. Whereas if it's containers, you can do it reproducibility, and that's also really good for, say, disaster recovery, clean up the infrastructure again, or just download containers and run them again.
So it kind of makes you a little bit independent from the underlying hardware infrastructure on which these things run.
Yes, definitely.
It's also interesting that you mentioned reproducibility, because it also has a meaning in science, right? So we want to be able to reproduce results.
Yes, so one of the projects I've worked on is something called Repo to Docker. That's a kind of way that's created by some of the Jupyter team. And it's a way to sort of encourage researchers to say, publish their sort of workflows and algorithms just like in a sort of public open repository and have a way for anyone to sort of run it and download it easily. So the idea is that there's a sort of specification where it has the dependencies. So it might be the Python requirements file or the R equivalent and so on. And then you actually have some, say, Jupyter notebooks, put all those in the GitHub repository in the right format. And there's a tool called repo to Docker, which you can run. It will pull a GitHub repository or any other Git repository, automatically build a container based on the contents of that repository, start up, say, Jupyter Lab or maybe RStudio. The idea is then you can run someone else's Jupyter notebook without having to do much setup of the dependencies.
Which is another question that I actually have. Using containers, you mentioned a number of benefits, and including reproducibility, etc., and also maintenance. But it could also be a little bit of work to actually get them up and running. How much of that can you actually automate? You hinted at it already with GitHub, but how much can this process be made a little bit more lightweight, shall we say?
So there are sort of quite a few tools that aim to sort of, it's almost like sort of layers upon layers of abstraction. So there are some sort of tools that try and sort of abstract away the process of building a container. So say repo to Docker is one of them. If we go back to, say, the example, say, running a Jupyter notebook that requires some Python dependencies. If you were to build a container from scratch, you need to find a container that's got Python. Then you need to make sure it's the right version of Python. You then need to, say, install the dependencies using pip or conda or whatever. You need to install Jupyter Lab, copy the notebooks in, and then set up all the sort of the command to make sure everything starts correctly. The idea of repo to Docker is to hide a lot of that. So you just give it, say, the GitHub repository with the Python requirements file, your Jupyter notebooks, and it automatically builds your Python environment with Jupyter Lab, your requirements. And then when you run it, it starts up. And there are sort of quite a few other technologies sort of along the similar lines. If you ever use something like, say, Heroku a while ago, when it's modern equivalents, they are kind of do something similar where they say, you have the source code for, say, your web app, your dependencies, and then they spin up the web app for you. And internally, they're sort of deploying a container typically, but that's all sort of completely hidden. I can't remember what the modern version of Heroku is called.
Are there any circumstances in which you'd say you wouldn't use containers?
Containers are always going to add an sort of additional layer of abstraction. So chances are that's going to impose a small sort of performance hit. I mean, most of the times I think it probably doesn't really matter, but I think it's worth bearing that in mind. And the other thing is, like, say, with some modern languages, especially something like, say, Go, which spits out a single self-contained binary. There's no harm running that in a container. But on the other hand, because it's a self-contained binary, it's also arguably no need to have that added complexity. And then the third reason is containers are very good for like hiding a lot of the complexity of your software. But the problem is you need a container engine to run it, whether that's Docker or Podman or something else. So that does impose an additional burden on your users.
So you mentioned Podman a couple of times now, and previously Docker. Are they equivalent? Is one working better than the other, or how would you compare them?
I'd say for most people, they're probably equivalent. I mean, one nice thing about Podman is that it can run without root privileges, which I think Docker can now, but it didn't used to. If you're using, say, Red Hat or Fedora, you're probably going to go with Podman because that's what's available in the default repositories.
And the final question that I have for you is then, are there any tips or recommendations that you could give listeners when they work with containers?
I'd probably start with thinking about what do you want to achieve by using containers. Say for me, most of the main benefits are actually reproducibility of a deployment or the reproducibility from, say, research sense. But I would say it's no point using containers just because you've heard about them and they sound cool. It's like any other technology. There's loads of tutorials available for explaining what a container is, how to use them, and so on. So I say just go and follow some of those tutorials. Stick with stuff like Docker or Podman to begin with. Kubernetes and other orchestration systems are really really interesting and useful if you have a need for them, but they can be very complex. I wouldn't start with them. Yeah, so basically, if I could also mention one thing that came up in the RSE Slack recently. So there was a conversation about use of containers for reproducibility, and someone did bring up the really good point is that actually it's not a panacea. So, for example, if you don't build your container correctly, or if you put up a Docker file, for example, but you don't put a built container, that's not necessarily helpful because your Docker file isn't necessarily reproducible on its own. Basically, when you build a container, your Docker file is a set of instructions to pull down your dependencies from, say, external repositories and so on. But because you've got that external dependency, if you rebuild it a second time later on, you might get a different container built, for example.
Yeah, I think that's quite an important point, actually, which we haven't talked about, is because you mentioned the Docker file. So if we stay with Docker, you have a Docker file, and of course you can have errors in them. So you need to make sure that before you actually distribute and share it, that your Docker file actually does what it says on the tin.
I guess the thing with Docker is there's kind of two aspects to it. There's a Docker file, which is like a set of instructions for building your container. And then there's the actual container, which is maybe, say, several hundred megabytes, even potentially several gigabytes. So say from a reproducibility perspective, you want to, say, publish both of them, but you want to publish a Docker file that tells someone how you built your container. And then you also want to publish your container itself that someone else can then download and use. Basically, the fact that you can build your container from that Docker file proves that the Docker file is correct at the time it was run. And you can do that in, say, your GitHub CI or any other system as well.
So Simon is using Podman for containerization. Personally, I confess I haven't worked with Podman before. As I said, in our projects we use Docker. So what about Podman then? For Simon, it's relatively straightforward. As he said, Podman has been developed by the Red Hat Linux team, and Simon is working on a Red Hat Linux. But how easy is it to run, say, on a MacBook Pro, which is the one that I'm using? I spent a little bit of time to find out. And as it turns out, it was pretty easy and quick. To install Podman, I used the Homebrew installation tool with the command line brew install Podman. Podman says that for that to work, you should install a Podman version that is at least 4.0, which actually wasn't a problem as my version came with Podman 5.3.0, but you can check with the command Podman --version. To run containers, we need to fire up a Linux virtual machine first. In Docker Desktop, this is done behind the scenes. Podman, on the other hand, is a little bit more explicit about this. You start a virtual machine by using the command in your terminal podman machine start. And since this was the first time I ran it, it began by downloading a lot of stuff, after which I ran my first test container. And when I'm done, I pull down the virtual machine again with the command podman machine stop. If you are running a Windows-based machine, the installation instructions will be a little bit different, but you can look that up in the episode notes. Things, of course, get more interesting when you want to create your own container images using Podman or Docker. And in fact, the way you do this is pretty much the same for both. The command for Podman is podman build, just as it is for Docker with Docker build. In fact, the commands and syntax of the container files used in Podman is also what Docker has. Podman can also reuse your Docker-based tools. And if you're thinking about migrating from Docker to Podman, there is a help page in the documentation as well. Why talk about Docker and Podman? Well, the discussion on whether to use one or the other has flared up since Docker changed its license agreement sometime around the summer of 2021. Simon and I alluded to that already in our conversation a little bit earlier. Docker is, let's be honest, still a great technology, and let's not forget it spearheaded the development of containers in the first place. And if you use it for your own personal use, or in an education environment, or for a non-profit organization, then you should be fine without having to pay for a subscription. But sometimes research software does move into the private sector, either by being adopted by other companies, or for researchers who want to set up their own business. In short, things got a bit more complicated with a new license. So if you want to use Docker, check the license agreement first. Coming to think of it, you should probably do the same for Podman. But with that in mind, I think both Podman and Docker are great tools to get started with containers. There is rather a lot more to say about containers. For instance, I haven't touched on containers for high-performance computing, for instance, or how cloud services such as Amazon Web Services, Azure, or Google Cloud use them. Or indeed, how you manage running several containers with a tool like, for instance, Kubernetes. But, as Simon said, it's best to start small and simple and get into the more complicated stuff where and when you need it. And with that, we're coming to the quiz. Well, we talked a lot about containers and virtual machines and virtualizations in this episode. So my first question is, how is a container different from a virtual machine? And my second question is, if you want to make sure that you run a certain version of Python, in the container that is, how would you do that? Have a think, and if you like, you can email me your suggestions and answers, or share them on LinkedIn, Mastodon, Slack, Matrix, or Blue Sky with me. I included a lot of links for this episode, and I encourage you to check out at least some of them. And that's it for this episode on ByteSized RSE. In the next one, in December 2024, I will treat you to an episode on how GitHub can help you with project management. In the meantime, if you would like to support the show, go to my Patreon page. Thanks for listening. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.